Hello and welcome to an introduction to research data management. I'm Chris Emerson, the university's research data manager, and I'm actually based in a team called the Research Data Service. I head up that team, and we are a partnership between the library, where I'm based, but also colleagues within the IT service, research strategy and development, and faculties themselves. And we were set up for two purposes. One, to look at the infrastructure behind the scenes at the universities to see what tools and improvements we can propose and develop to encourage researchers to manage their data more appropriately, and secondly to support researchers in that management of data to make sure that data is managed effectively over the course of a project. Over the course of the next 15 minutes, I'd like to really just kind of give you broad brushstrokes over data management, introduce some key themes and areas, and really propose areas for future discussion for yourselves. So first of all, look at the landscape. Actually, what is data management in terms of where we're coming at in terms of the research funders, and then also look at the data lifecycle itself and introduce that as a topic and really break down a lifecycle and the nature of a project over the course of planning, working and sharing. So first of all, the landscape. As I mentioned, I'm part of the Research Data Service, and at Newcastle University we were set up in 2015. And that was really the back on changes within the wider funder policies. So we had the RCUK, so all the funding bodies which receive money from the UK government to distribute for research grants across the UK, outlined in 2011 that actually this is how researchers should manage their data, and it's appropriate that they manage it effectively and share their data where appropriate. In 2015, the EPSRC, which is the big engineering council, spun out of the RCUK, so they're part of the common principles, but they spun out in 2015, like Fraser spun out of Cheers, and actually outlined their own requirements, but actually this time held the institution responsible for data management, not researchers. And that's a big, significant change in the landscape for data management. And if an institution was found not to be providing adequate support to their researchers, they would potentially withhold money from that institution. So it's no coincidence that the Research Data Service that I head up was created in 2015 by the university to support this process. And more recently we've had changes within the European Union and their requirements for data sharing, and then the Research Concordat on open research data as well. And that's based on the UKRI, which was essentially RCUK, so again all of the funding bodies, of which there are 7, plus innovation. So this is kind of the landscape in terms of the external factors affecting researchers and research projects. But it's also important to note that actually data management is a key element of good research conduct. It's certainly not something that the research funders came up with. It's not new. Researchers have always had to manage their research data from the birth of modern science and think about its management over the course of a project. So it's not a new thing. There's just stronger external factors on researchers to consider in this broader landscape of additional support. If we kind of delve down a little bit and actually what the research funders require, right back from the common principles and more recently in the Concordat, there's some kind of two key areas it's worth highlighting. So first of all, this idea of data management plans are created, and this is a planning document where a researcher would outline the approach to the project, what data they're going to collect, where it's going to be stored and how it's going to be shared, and they do that at the application stage. But also I'd encourage all research projects of all size and scale and complexity to at least have half a page on actually just the nature of the data, and we'll cover that in a little bit more detail in a couple of minutes. Secondly, the big step change from the research funders was actually that research data is archived and shared, and especially for data that underpins publications and the data of long-term value. So this is moving away from the idea that researchers would place in their publications or on their web pages and say, contact me and I can provide access to the data, but more of a formal sharing of that data. So it's archived, so that means it's preserved for future reuse, but also people can get access from around the globe, and not just in terms of contacting the research, and they have overall governance of that data. And then the research bodies are having more of an interest in actually monitoring the actual archiving and sharing aspect of that data that's been collected, and that's interesting in terms of wider policies and the carrot stick of actually changing behaviour within the management of data. So that's really briefly the kind of landscape of it. Spend the majority of the presentation really on the life cycle of the data and considerations across a project for the approach to data. So if we actually look at the data life cycle, we've got here right at the top planning, which is the circle at the top, the brown circle. This comes back to the idea of data management plans. So before any data is collected or created, researchers should plan for that data. But once they do actually collect or create the data, which moves on to the next circle, the green circle, and create. So once they've created or collected, that data needs to be stored somewhere, and we call that active data storage. So somewhere where you're actually going to place the data while you're working on it. And while you're working on it, you're going to be processing the data. So you're going to be taking the raw data, using analytical tools to process it and produce new insights and findings on that data. So you've got your research questions, you've identified what data you need to collect or create, you collect it, you store it securely, you analyze it, and then you traditionally publish from it. And at this stage, there's generally a kind of an element of data selection. Quite often you would need to keep the raw data that you've been collecting, but once you've got the processed version, that's what's valuable. But it really does kind of depend on the nature of the research discipline. Traditionally, this is kind of the broad research activity. This is what all researchers are trained to do. It's what research-intensive universities like Newcastle University is set up to support traditionally, kind of pre-2011. This idea that researchers are going to naturally collect or create the data that they need to answer their research questions, store it somewhere, process it, produce new insights and findings, and publish from it. But as we can see from the kind of broader life cycle, is that doesn't include the planning aspect, and it doesn't include what happens to the data after the research project's finished. So we actually move along the life cycle. We can see that there's actually archival storage requirements there, so this idea that once the researcher is finished with the process and produced new insights, the data is then preserved, and that data is then moved from active storage to archival storage. In the same way that you would take your Christmas decorations out from underneath the stairs or from the loft, you would put them out, so they would go from archival storage to active storage, and then you would put them back again as well. And hopefully once you've kind of archived the data, you can potentially also share that data as well, so it becomes visible for other people to use, so kind of a public facing storage aspect. So you've got the archival storage, but a layer of public accessibility on top of that. And again, at this stage there might be an element where the data will be potentially deleted at this stage to consider the nature of the data and whether you want to share that data, and ultimately for that data to be reused in the future. So actually data management is essentially the active management and appraisal of data over the life cycle of scholarly or scientific interest. So when the next project for a researcher comes along and they start the planning aspect, the first consideration is to consider what data can be reused before automatically assuming that you're going to collect or create a new data. In the drive from the research councils and supported by broader initiatives around open research, open science, and certainly by the Research Data Service, is for the research activity to actually encompass the full data life cycle, and for it not to just be to create, collect, process and then move on, but to think about the nature of the data as it goes through the life cycle and actually archived and then potentially accessed for anyone to reuse in the future. Now, as a research data service, we actually break down the data lifecycle to 3 key stages, which was mentioned in the overview, is to think about the planning aspect. So before you've collected or created any data, the working aspect, essentially where's the data going to be stored during the project and how is it going to be processed and analysed. And then the big one, especially from the research funders and the broader landscape, is for that data to be shared, so the sharing aspect of the life cycle. So what I'll do is I'll just cover each one of these in a couple of slides just to kind of get the ball rolling for you to think about. and hopefully you'll some further resources at the end. So first of all, the planning aspect of the data lifecycle. Essentially, this process is there to help you manage your data. That's the whole point of it. It's a project planning tool. And because it's a planning tool and used before you've collected or created any data, the ultimate aim is to make sure that you make informed decisions before you've collected the data. So you don't have to figure things out as you go through. And then you not have considerations with or potential implications around data loss, or not considering your storage requirements, or not considering where the data is going to be shared at the end. But this has actually been thought of ahead of time. And this is really important for all research projects, but especially for larger projects when there's multiple project partners. And the kind of a big driver across the higher education sector at the moment is to have larger multidisciplinary, interdisciplinary research projects where you're going to have project partners right across the UK, EU and the world, and to have data being stored on each of those sites and transferring and moving around through modern technology adds complications to the safe management of the data. Now, as I mentioned from the research funders, they introduced something called the data management plans. And essentially, this is a kind of a 1 to 2 page document where it outlines a project's approach to data management. It is a requirement for all funding applications, so generally researchers have to do it, but I would encourage it to occur for all researchers. And within this data management plan, essentially you consider 6 key themes. Now, I don't have time to cover them in detail in this presentation, but hopefully it'll start you to think about your research projects, and to think about actually what is the data you're collecting in terms of data types, file size, and actually the number of data types across one aspect of data collection. So for example, if you're going to be collecting interviews, you're going to have several data sets that wrap up to make that interview. So the likelihood is you'll have the audio transcription if it's been recorded. You'll then have the textual transcription of that audio recording, and then you may also have notes on top of that. So traditionally you would say, I'm going to do interviews, but when you actually apply a data management plan to it and say what is the data that makes up those interviews, you could potentially have 3 independent data file types which make up that one set. So it's really important you start breaking it down. You then move on to metadata, content and format, and this is essentially metadata means data about data. So what is the data that you've collected? And the driver behind this is, if you were to go back to your data set in 5 years time, and remember there's a strong drive for reuse of data in the future, is if you're going to collect this data and work on it, you need to provide essentially the recipe for that data. So you provide some documentation that sits along with the data, so when people access it, they understand what the data is being collected for and how you've analysed it. Then moving on to the third consideration, project storage. Where's the data actually going to live during your project? So that active data storage, and making sure that's got sufficient data security around it, especially if you're transferring data across different sites and project partners. Then data sharing, which is what the research funders are particularly interested in. Where's that data going to live once you've finished with it, and who's going to have access to it? And we'll cover that in a few slides' time. And the preservation of that data. So actually you're sharing it, which is great, but how is that data going to be preserved so in 2, 3, 5, 10 years time the data can still be accessible? And then the roles and responsibilities. Who's in charge of the data management? Can that be devolved to anyone? And especially for those larger grants, to make sure that everyone has understanding. So that's a quick introduction for data management. We do have some additional guidance on our web pages which you can read through and get a greater understanding of it. Moving on to the next section of the data lifecycle, this idea of active or working. And essentially it is active storage. So where you're going to store your data during a project. Now at Newcastle University we provide a few options. We've got FileStorm, and you would have your H drive, which is a 20 gigabyte drive, which is backed up daily. Very fast processing, so you can do a lot of analysis on your H drive from that. But if you go back to the planning stage and think about the first section, which is what data are you going to collect, within that it'll be how big is the data, the scale of the data, and we talk about planning as a tool to anticipate and avoid problems. One of them would be, is your data set that you're going to collect larger than 20 gigabytes? Now if you're going to do a lot of audio transcriptions or video or modeling, very quickly 20 gigabytes isn't going to be enough. So it's to preempt that process. There may be access to a school storage you can access, or potentially we also have Office 365 as an offering for data management, and this is where everyone gets access to a OneDrive account, which is 5 terabytes of storage, so significantly more. Also you can create a team which comes with a terabyte of storage, and this has multiple backups. It also can be accessible off-site, so it is much better for flexible working. But one of the challenges around this is it is cloud-based, which means you can access it anywhere, but it doesn't have the same processing speeds as the file store. So maybe that you use this as your archival copy during the project, but you may have to kind of download it onto your H drive to process it and then put it back up into the cloud, if that makes sense. And these are some of the challenges around data management, why it's important to think about it ahead of time. Because it's Office 365, so it's a Microsoft product, you can do some analysis in the cloud, so it's slightly slower, but it is restricted to Microsoft products. So you can do some Excel work, obviously Microsoft Word and PowerPoint, so you can work on that collaboratively. But in terms of analysing data, if you wanted to use anything that wasn't Microsoft, then you can't use it. You can store it in Office 365 in a OneDrive and Teams, but you can't process it. And again, that is a challenge we've got. But if you don't use the university provision, what you can very quickly do is to end up in decentralized storage. What that means is you use your own solutions, so kind of USB devices, external hard drives, laptops. They're all external provisions of storage, and they're all fallible for data loss or data breaches. For example, laptops is essentially a glorified USB stick. If you store all of your data on a laptop and then leave that laptop on the train or in the pub, that data is being lost. It is not backed up. It can be used as a secondary backup during field collection, but not your primary backup. Other cloud storage provisions such as Dropbox, Amazon Web Services, Google Drive, they're great. They offer the same flexibility of Office 365 and OneDrive, but the university doesn't have a contract with these providers, which means that the data is quite often, the storage is on somebody else's computer and you don't know where that computer is, and quite often that's outside the European Union, which has GDPR implications. And it's quite often that you'd only end up with one copy in one location. For example, the laptop overview I'll give you is to think about the nature of the data and where you're storing it during the project, and to use university provision wherever possible. And quite often people rush through the data lifecycle and forget about planning and rush to collecting and creating, and then active data storage is quite often forgot about, and it will result in actually not managing the data effectively. And it's the management of the data, and the data itself is what all projects live and die by, because the quality of the data has a direct implication on the analysis and processing, which gives you the new insights and findings. And if you don't manage that asset properly, the insights and findings aren't going to be as strong as possible. And one of the big challenges is to ask researchers to estimate how big the data is going to be, which is an unfamiliar process to do. We all work in a digital universe now and we don't think about the size of it, but when it comes to research data, it's very important you understand what your storage provisions are and how much storage you need, and then to work out your method of storage across that. If we move on to the final section on terms of data lifecycle, is the sharing aspect. And think about the benefits actually first of data sharing. So why are the research funders particularly interested in it? Why is there a growing drive for transparency to make sure that there is open research or open science? And essentially it's there to encourage scientific inquiry and debate, to allow other people to see the data that underpins findings, and for allow that data to be reused in the future. It does lead to new collaborations between data users and data creators because you're not reliant on meeting somebody in a conference or reading someone's paper. The data is then accessible for everyone, so it does lead to new collaborations. There is an element of transparency and accountability to decrease data fraud for those researchers who have been found out that have made up their data sets. It's becoming harder and harder for that to occur because the data should be archived with the publication and a link created, which means that people can see the findings, the publication, the book chapter, but also get access to the data as well, which directly leads to the scrutiny of research findings. It also improves the impact and visibility of research across the board because you're archiving it officially, and it means that people can see papers and how research outputs and data sets as well. But also, if anybody wanted to reuse that data in the future, they would have to provide credit to that researcher to do that. In terms of the obligations to actually share the research data, quite often there is funder obligations. So every UKRI and major charity expects data to be shared. So when they provide research grant money, they expect that researcher to manage the data appropriately as based on the common principles, but also for that data to be shared. Institutionally, the university has a research data policy, and they expect that data to be shared where appropriately in an official repository. But there may also be a personal obligation in that actually sharing is caring, and there's a lot of benefit to the broader scientific community for that data to be collected, and once you've finished processing it and you've produced all the insights you want to share it, to allow another person, another research group or a member of the public to actually ask a different research question of that data. Now the best way that data is actually shared is through a data repository, and this applies essentially to the FAIR data principles. This idea that data should be fair, which is an EU directive. And what fair means is that the data is findable, accessible, interoperable and reusable. So actually data can be reused in the future. People can find it, but when they do find it, and to allow that reuse, they can actually get their hands on the data, and also it's provided with documentation and in file types that allows that reuse to happen. At Newcastle University, we have launched an institutional research data repository called data.ncl. This allows our researchers to archive their data, to share their research data, to make their data fair, where there isn't a repository already in place. So it means in terms of when they come to share their research data, they can put it in data.ncl and then they can share the research data. But also it becomes a catalogue for anyone to browse and access data sets produced by Newcastle University, and it's powered by a repository called Figshare. And then you can also share other institutional repositories which use Figshare as well as a way to actually find data sets to potentially reuse in the future. So just to wrap things up, research data management is essential. It's a part of all research projects. Whether the researcher plans for it or not, it's always part of it, and essentially the better you can do it, the higher quality research is. Definitely planning is the first step. Essentially with a data management plan, even if it's half a page to a page, it's a lot better than not doing it. And really what we do at the Research Data Service is just consider the nature of the data at each stage of the life cycle. So consider at the planning stage, which takes into account the full life cycle, the working aspect in terms of active data storage, where's the data going to live during the project, and then sharing, the nature of the sharing in terms of where's the data going to go, how are the people going to find it, is it accessible, is it interoperable, and will it allow reuse. So that was the introduction to research data management. We have some additional guidance on our pages, also the repository is browsing, and we do have a contact email address if you would like to ask any further questions, or you can use the online tool as well. So thank you very much.